Well, thank you everyone for joining this Base SubQuery virtual workshop on data indexing. Super excited to be here. Let's get straight into it. The agenda for today's session will be running for about 20-25 minutes, taking a look at a couple of things. First of all, what is the problem we're trying to solve? And we'll see how SubQuery approaches this with a solution in mind. And then we'll jump into a quick little demo. It's a live demo, so fingers crossed it will work. I did test beforehand, but you never know. And if you are following along, you're a developer, feel free to do so. And then we'll have some Q&A at the end. But if you do have any questions throughout the presentation workshop, feel free to jump in and put it into the chat window as well, and I'll try to answer it. So first of all, what is the actual problem? Well, for the developers on the call here, you may know that when you're building your wonderful decentralized applications, your dApps, you need to get blockchain data, right? So how do you do that? Well, yes, you can go and connect to an RPC blockchain node. However, as a developer, you want to do what you do well, right? You don't want to worry about the plumbing or the cumbersome nature of trying to get the actual data into your application. So what we do is try to solve the problem of where and how to get blockchain data. So SubQuery is an end-to-end blockchain indexing solution where there are three main parts. The first one on the left-hand side here is we've got an open source data indexer SDK. So anyone can go and download this and run it. And this is what we'll be showing in the demonstration today. And then once you've got this project up and running on your local computer, your local host, you're going to have to host it somewhere, right? It could be AWS, it could be Google Cloud, or you could go ahead and choose the SubQuery Managed Service solution. And then on the right-hand side here, the third option is that we've got this decentralized network marketplace. And this is actually where we're heading. This is the end goal, where the idea is that we've got network participants such as, say, indexers. Indexers take projects, they run it on their infrastructure, and then they serve data to consumers. Anyone who wants the data can pay for it as a consumer to drive their applications. And then the other network participant are what we call delegators. These are people who can stake tokens in the network, so to speak. So at a very high level, these are the three aspects of SubQuery itself. And a lot of people ask, well, why use SubQuery? What's so great about it? Well, there are a number of reasons, actually. Starting at the top, as mentioned, is open source. However, it's also quite easy and simple to use. It's easy because we use a Dockerized container environment when you're developing your projects, so you can literally get up and running really quickly. It's also simple because there's actually only three main files you need to know about, to learn about, and to modify. The three files are the schema, the manifest file, and the mappings file as well. So we'll talk more about these files, and I'll show you what they look like just before the demo. It's also very customizable as well, because in the schema file, you can actually specify the exact data you need to drive your dApp, which could be, say, a mobile crypto wallet, for instance. So I'll just jump over this one into the fast feature, because when you specify just the data you need, the project becomes quite lightweight, therefore very fast to get the data from the blockchain to drive your application. Now, jumping back to being feature rich, there's a lot of features, and some of them include scaffolding projects with what we call an ABI, which is an application binary interface, and you can actually pass the contract address to the SubQuery project when you're initializing it, and it'll actually grab all the functions and pretty much pre-build the project for you, so that's 80% of the work done. There's also other features such as syntax discovery, there's historical state querying, and a whole bunch of others also. It's also real time, you can see here. It can access the data on the blockchain very quickly to make your apps very responsive. And it's actually what we call multi-chain. And this is quite an important aspect because not only can you go ahead and grab data from, say, Base, the EVM network, you can go to another EVM, you can go across networks to, say, Polkadot, Cosmos, Near, Algorand, etc. And you can do all of this in just one project and effectively have a single API interface to all of this rich data. As mentioned, it's flexible with the different hosting options there, and it's compatible with EVM and WASM, and that's important because we know how big the EVM space is. So just a quick overview here of the supported networks. As mentioned, EVM is very large, and you can see Base is here along with a whole range of others. And then down below we've got Cosmos, Polkadot, and Algorand, Near, etc. And we're all continuously growing as well. Okay, so let's zone now into Base in particular, where you can see that we've got what we call a starter project ready for anyone to use. And this is on the GitHub repo. And what I can do is, let me just go and show you this repo. So this is the SubQuery network, and down below, if I do a search down here for, say, Ethereum, you'll see Ethereum SubQuery starter, and then it's in here. Yeah, perfect, thank you. You can scan for the other networks here, but if I go into Base, you'll see there are a couple of projects here for some of the networks. Go early, for instance, there's a starter and an NFT example as well. So in order to get up and running really quickly, there are some prerequisites. And if you're a developer, you've probably got a lot of these already. The first one is Node.js. So just run brew install Node, for instance, on a Mac, or just download it from the website. And same for Docker as well. Now, what you might be missing is the npm install SubQuery CLI. This one here, you can see, will allow you to run the project in your command line and actually initialize a project. I can see a comment there. We need Marta. Her voice makes us sleep better. Oh, love it. I'll pass that on to Marta and get her on. Get her on the next one.
I'm going to grab the link to the NFT folder, I think is what you said we'll be going into, right?
Correct.
Cool.
Correct.
So, Base NFT. I'm going to post this in the chat, and y'all can grab this code here.
Awesome. Thank you so much for that. Okay, so to get up and running, there are 3 simple steps, right? First of all, we want to define the shape of the data that we want to index with what we call a schema file. And then after that, we want to tell the project where we want to get the data from. So we'll point to the endpoints and any filters we need. And then the last piece of the puzzle here is we'll transform our data in the mappings file. And this is where the programming takes place. So what we'll be doing today is we're going to index all the claims from the bridge to base NFT contract on Base Mainnet. So as mentioned, some of the links are provided in the chat there. You can also feel free to scan the QR code taking you to the GitHub repo, and also the quick start documentation for future reference as well. Okay, so let's jump in, and I'll go into VS Code here, and I'll just make this a bit bigger. And what I'll do is I'll run a command called SubQuery init, which is to initialize a project, and I'll call this, say, base demo, say, let's go v1, like so. I basically ran the command SubQuery init gave it a name, and then it asked me to select a network family. So I can select a couple here, but I'll go into EVM network, and then you can see all the options I have to choose down here. So I'll go to base, hit enter, and then I'll choose the base NFT one that we'll be going through. And then what's going to happen is on the left hand side, you'll see I've got a base demo v1 up here, and then I can go ahead and provide an RPC endpoint. However, you'll see that there's a default one provided already called mainnet.base.org. Let's go enter, and then I'll accept the defaults again in yellow just for the this demonstration. And there we go. Now,
it automatically created the folder when you chose the base NFT.
It does. It does.
But cool. Okay.
So it's all the scaffolding's there for you, and I'll jump in very shortly as well. Now, here it's asking if we want to generate more code from an existing API contract. So it's here where you can copy in the smart contract, and then it'll basically, as mentioned before, take all the functions. But I'll go select no for now, and there we have it. So the first thing I want to do is let's go into this directory, and then I'll go yarn install. And what this does is it just installs all the dependencies. It'll take about a minute. So while that's running, let me go ahead and open up the schema.graphql file that I mentioned earlier. Right, so this is what it looks like. There are a couple of entities. There's a claims entity and a daily aggregation. And these entities you can think of as tables in Postgres, for instance, because they actually translate to a database table. And then the fields inside are the database columns. So we're choosing to index the ID, block height, timestamp, claimer, receiver, etc. that you can see here. So this is the shape of our data. And then if I go into the manifest file, and I'll scroll down, a lot of these configurations you won't have to change. However, if you look at the endpoint, this is where the data is coming from. Oops. So as you saw earlier, it's mainnet.base.org, and then another RPC here. And the neat thing is that this is an array, so you can provide more than one endpoint, because if one endpoint gets stuck or has a problem, then the project will try the next endpoint. Down below in the data sources section, I can specify a start block. So at the moment, I'm starting at around 2.1 million. But if I made this 1, then I'd be indexing from the Genesis block, right? So it depends. I mean, if you're indexing a particular contract that started at a particular block height, then you want to start at that height. You don't want to go back to the beginning.
John, what's the dictionary that's under the endpoint?
Yeah, really good question here. So a dictionary helps the project index a lot quicker, right? Because what happens is that there's an existing dictionary that has gone ahead and indexed the base blockchain, basically, and it's made a note of various bits of information. So what this project does is it goes to the dictionary and says, hey, based on the filter down below that you see down here, for example, tokens claimed, it goes to the dictionary, hey, I want to grab all the tokens claimed, right? Where do I go? And then instead of looking at block 1, 2, 3, 4, 5, the dictionary is going to say, hey, you'll find this in block 2,640,000, 2,830,000, etc. So then the project will know exactly what block to go to get the data.
So that's what makes it so fast, right?
Yeah, exactly.
Yeah, that's cool.
Down here you can see we've got one handler called NFT claim. So this handler will get triggered when it meets the filter criteria. And then what we'll do is if I jump into the actual mappings file on the left-hand side, it's here where a lot of the grunt work is performed. So you can see here the function called handle NFT claim. it receives an argument called log of type token claims log. It logs some information to the console for debugging purposes, and then down below here it grabs or creates a new object, a new claims object, and it gets the data such as timestamp, claimer, receiver, these addresses from logs.arg.claimer, etc. So it's basically extracting the information that you need, and then down below it'll save it to the database. This other function here is just a helper function to help aggregate the information in order to get aggregated data as well. Great. So those were the 3 files. Now down below you can see that we have downloaded the dependencies. So the next thing I want to do is run yarn code gen, which will generate the type scripts, or the types actually. And then I want to run yarn build to actually build the code. And then the last thing I want to do is make sure that I've got Docker running, which it already is. And then I can run yarn start Docker. Now, there's actually a bit of a shortcut, because if I go to my package.json file, you can see here we've got the build, the code gen command. But if I run yarn dev, it'll actually run code gen, build, and also start Docker all in one command. So basically yarn dev, and it will just kick up a Docker image immediately. So I've actually done it the long way. So if I go yarn start Docker, and let me open up my Docker here. This is my container. You can see that this image, the project is downloading 3 images. I've got a Postgres image, my database, I've got my node, and then the GraphQL engine as well. So
what are the resource requirements for the container? Is it?
Yeah, at the moment,
You need to have
I think my Docker environment, I've got maybe 4 CPUs, 4 gigs of RAM. I mean, it does vary based on what you have, but yeah, it's not, and it depends on the project. I mean, this project's not too taxing, so to speak, but yeah. Okay, so we've got this up and running. Let me go into, the README file, because in here there is a sample query that I can run. Let's copy this, and then I'm going to open my browser and go to localhost 3000, right? So refresh that, and then what I can do is paste this in here, hit play, and you can see I've got data coming back already, right? And you can also see this in the console down here too. So that's good news. It's actually working, which is great to see. And I'm only limiting the queries to the first 5, for instance. So that's why there's only 5 results. And you might be asking, well, how can I cross-check this? Well, what I can do is copy out the ID here, and then I can go into basescan.org. And then I'll copy this, the transaction ID, search for that. And then what I can do is you'll see that this particular transaction here has a quantity of 1. And the quantity of 1 is what you see here, right? We can also
Can you paste the link, Sean, into the chat?
Yeah, I can.
You're looking at your VS Code. That'll be, there you go. Thank you.
Yeah, perfect. And you can also see the block height here is 157, 157, and the address will match as well, F5C.
Well, yeah.
F5C over here. There we go. And then if I scroll down a bit, you'll see that the daily aggregation is 3,100 at the moment. So it's continuously aggregating it as it indexes. Cool.
Yeah, and then I think if you want to switch back to the Etherscan. Thanks, Marta.
So there we go. Let me just stop this. And let's go. Okay.
So,
Give me
Sean, when you were setting that up, like you ran the command line, and like you ran the command, like I didn't see like do you need an API key? Was that free? Like how does that whether the authorization work?
Yeah, so these are public API endpoints at the moment. These endpoints here. So there's no authorization required. There's no API key. So what happens is that some of the endpoints may be rate limited, for instance, or limited in speed, etc. Number of queries.
Then like to leverage the dictionary that also is free. Like I like how does I guess anybody can just start using this right away. It sounds like, right?
Correct. The dictionary is free as well. Yes, hosted by SubQuery. Okay, so let me jump back into the slides here. Just a screenshot of what we saw earlier, comparing the results from the Playground, the project, with the Block Explorer. So just wrapping up with a quick summary here, we took a look at what is SubQuery and why, what are the advantages of SubQuery. We looked at the 3 simple steps to create a project, which was basically manipulating or editing the 3 files, the schema, the manifest, and also the mappings file. And then we indexed all the claims from the bridge to base NFT contract on Base Mainnet, open source code. Anyone can go ahead and in a few simple commands run it as well. And as mentioned, the decentralized and tokenization of the network is the next big thing for SubQuery, allowing you to completely decentralize your application stack. We've got a Kepler network which is live at the moment. It's in closed beta, but it is working, undergoing a lot of testing as well. So feel free to register and check it out as well. And if you want more information, there's our documentation at academy.subquery.network. And a couple of more links. Feel free to reach out on Discord or Telegram. So many ways to connect nowadays. So with that, happy to open the lines up for some questions.
Yeah, that was awesome.